Hi ma'am, good day. Today, I'm going to explain the three energy systems that our body uses. The ATP-PC system, the glycolytic or lactic acid system, and the aerobic system. I'll also talk about how these systems work in different activities, the role of ATP in energy transfer, and how all of this affects our performance. So now, uh, let's start. Let's start with the ATP-PC system. So this system gives us quick and powerful energy for short movements, like for example, sprinting, uh, jumping, or lifting something heavy. It uses the energy already stored in our muscles called phosphocreatine, but it only lasts around 10 seconds, so it's great for fast, explosive actions, but it runs out quickly. Next, we have the glycolytic or lactic acid system. When we keep moving, after the first burst of energy, our body starts to break down glucose or sugar from food to make more energy, this time without using oxygen. That's why it's called anaerobic. It lasts around 30 seconds to 2 minutes. A good example is a 400-meter run or a fast-paced sports where you move quickly but not for too long. However, this produces lactic acid, which can make our muscles feel tired and sore. And finally, we have the anaerobic system. This one uses oxygen to make energy, and it's the system we use for long-lasting activities like jogging, cycling, or swimming. It's slower but can keep going for a very long time because it uses oxygen to break down carbs, fats, and even proteins. So now, let's see how this system works in real life. So, uh, when you do a short sprint, you're using mostly the ATP or PC system, or what we call the quick energy. So no oxygen needed. If you run a 400 meter or 800 meter race, your body uses both the glycolytic and aerobic systems. Fast energy at first, then oxygen starts helping out. And also, if you're doing long distance running or a marathon training, your body mainly depends on the aerobic system to keep you going for a long time, and also without getting too tired. Now, let's talk about the ATP, which stands for adenosine triphosphate. So, ATP, the adenosine triphosphate. So, think of ATP as a battery that powers all our movements. So when ATP breaks down, it releases energy that our muscles use to contract, move. But since our body's stored ATP runs out quickly, these three energy systems are constantly working together to recharge it. That's what we call energy transfer. It's how our body keeps making more ATP to keep us active. So next, we have to how our body energy transfers impacts like performance. So let's talk about that. So energy transfer affects how we perform in different sports and activities. And also, for example, in sprinting, fast energy transfer helps you move explosively. Like in basketball or football, athletes use quickly bursts of energy followed by short rest periods that mix a adenosine triphosphate and a PC of and glycolytic systems. And for endurance sports like marathons, swimming, the aerobic system's steady energy transfer helps you last longer and avoid fatigue. So training these systems make your body better at transferring energy, which means improved endurance, faster recovery, and stronger performance. So to sum it up, our body uses three energy systems, which is ATP or the adenosine triphosphate PC for quick burst, and glycolytic for short but intense efforts, and aerobic for long-lasting endurance. So all of them work together to produce and transfer energy through ATP, helping us move, perform, and keep going in any activity. So that's all, ma'am. Thank you for listening.